finding theta. In our case, we decided using that the number in front of the I is equal to the magnitude of the vector times the cosine of theta. Sure, I said times. If I said plus, I must have. She had plus in her notes, and I was going, wait, how did that happen? So let's start with the magnitude. We'll do u. So what was the magnitude of u? You actually figured it? Well, I guess you don't have mine. So magnitude of my vector u is equal to what? Remember, u here is 8I minus 3j. Square root of 8 squared plus negative 3 squared. So what's that going to be? The square root of 64 plus 9, which is the square root of 73. So I now know that 8, the number in front of my I, is equal to the magnitude of my vector, the square root of 73, times the cosine of the direction. So to solve for the direction, because that's what I'm looking for, I would divide by the square root of 73. So I have 8 over the square root of 73 equals the cosine of the direction. And then take the inverse cosine. Now, the only problem is this might not actually be theta. You have to figure out where your angle, where your vector is. If the vector is in quadrants 1 or 2, then this actually produces the answer. If it's in quadrants 3 or 4, you need to subtract this number from 2 pi to get it into quadrants 3 or 4. Where is my vector? Remember, this tells me the x-coordinate, that tells me the y-coordinate, so it's 8, negative 3. So my vector is right here. Since it's in quadrant 4, then my actual direction is going to be 2 pi minus arc cosine of 8 over the square root of 73. And that you can type in. That was the part you were leaving off. Yeah, that seems to be the part that everybody forgets to check where their vector is.
For the last